Welcome to Part 7 of this series of slideshows that describe the mammalian stress mechanism that was predicted by Hans Selye. This presentation will introduce the capillary gate component that regulates hemodynamic physiology. This is my favorite part of Selye's mechanism because it is so counterintuitive. The capillary gate component generates and disintegrates insoluble fibrin in capillaries and flowing blood in accord with autonomic balance. It regulates blood viscosity, blood coagulability, cardiac output, blood pressure, pulse rate, tissue perfusion, and organ function. It simultaneously governs a submicroscopic capillary gate mechanism that regulates flow resistance in capillaries, and a turbulence mechanism that regulates flow resistance in arteries and arterioles. The capillary gate component consists of the autonomic nervous system, the vascular endothelium, von Willebrand factor, nitric oxide, and the enzymatic interaction of factors 7, 8C, 9, 10, and 13. Factor 8 plays a pivotal role in capillary gate component function because it links nervous activity to blood enzymes. It is an extremely unusual chimeric combination of two gigantic molecules that are produced by different tissues at different locations under separate genetic control. These bind together in blood and exert their effects in concert. Factor 8C is an enzyme that is continuously released from the liver. Von Willebrand factor is released by the vascular endothelium in accord with sympathetic nervous system tone and activity, but it has no enzymatic activity of its own. However, the 8C enzyme is extremely labile and cannot exert its enzymatic activity unless it is stabilized by von Willebrand factor. As a result, the enzymatic activity of factor 8 fluctuates in accord with sympathetic nervous system tone and activity. Defects in 8C cause hemophilia, which is a sex-linked coagulation disorder that mostly afflicts males and is continuously severe. Defects in von Willebrand factor cause von Willebrand's disease, which is a coagulopathy that afflicts males and females equally and fluctuates in severity in accord with sympathetic tone and activity. The capillary gate closes when stressful stimuli increase sympathetic nervous system activity that stimulates the vascular endothelium to release von Willebrand factor. Von Willebrand factor stabilizes factor 8C, which increases factor 8 activity. Factor 8 accelerates thrombin generation to energize its conversions of factor 10 to factor 13. Factor 13 adds crosslinks of plasminogen and fibronectin to soluble fibrin to generate insoluble fibrin in capillaries and flowing blood. Thrombin also stabilizes insoluble fibrin via thrombin-activated fibrinolysis inhibitor, commonly called TAFI. So long as thrombin remains elevated, the insoluble fibrin molecule remains stable. Insoluble fibrin consists of strands of soluble fibrin that are connected together by crosslinks of fibronectin and plasminogen to form a complex mesh structure that is illustrated by the figure on the left. It polymerizes into strands that entangle red cells into clots, as illustrated by the picture on the right. The plasminogen crosslinks in the insoluble fibrin molecule are unstable and they spontaneously degenerate into plasmin that attacks the insoluble fibrin lattice structure and dismembers it into fibrin split products. As a result, the insoluble fibrin molecule is inherently unstable and it spontaneously disintegrates into fibrin split products unless it is continuously stabilized by thrombin via thrombin-activated fibrinolysis inhibitor. So thrombin energizes both the degeneration and the stabilization of insoluble fibrin, and thrombin opposes the effects of plasmin. Nitric oxide is a gaseous molecule that is produced and released by the vascular endothelium. It binds avidly to ionized calcium and inhibits thrombin. Parasympathetic nervous system activity releases nitric oxide from the vascular endothelium, which binds to calcium, inactivates thrombin, and inhibits the generation and stabilization of insoluble fibrin. In the research literature, this is known as nitroergic neurogenic vasodilation. The capillary gate component explains why von Willebrand factor, factor VIII, insoluble fibrin, D-dimer, or that is fibrin split products, blood viscosity, blood coagulability, blood pressure, cardiac output, heart rate, tissue perfusion, tissue oxygenation, atherosclerosis, and organ function all fluctuate in accord with autonomic balance. Its acute hyperactivation causes infarction, pulmonary embolus, thrombophlebitis, and high-altitude pulmonary edema, or HAPE. Its chronic hyperactivation accelerates atherosclerosis and capillary senescence, which causes diabetes, hypertension, eclampsia, and congestive heart failure, and increases the risk and severity of infarction, adult respiratory distress syndrome, and multi-organ failure syndrome. It's time for another break. The next slideshow will describe the capillary gate mechanism that regulates flow resistance in capillaries and the turbulence mechanism that regulates flow resistance in arteries and arterioles. Thanks for listening.